Hi everyone. In this section, we are going to solve the initial value problem and boundary value problem using Laplace transform. All right, before this, in chapter 1, we have solved or we have learned few techniques or few types of ODE. Okay, so for example, you have something like this. Okay, so dy dt plus 1 over ty equals t squared. So in chapter 1, you know that this is linear equation. So you solve using linear solution procedure. Okay, and in the second chapter, you have something like this. Y double prime plus 4y prime minus 3y equals some function sine t, for example. And we have solved this kind of problem using method of undetermined coefficient. Okay, that's what that's what we did in the previous chapters. All right. And when you were given the condition, okay, so for example here, this one, so the whole system here is called the initial value problem. Okay, so if you're given two value at these 2 points here, then it's called the boundary value problem. Okay, now if we have slightly different function at the right hand side, so for example, if I take this one to be h t minus 1, for example, okay, which we know that this is Heaviside function. Okay, so ht minus 1. Then what we have learned in chapter 1 is not applicable here. The solution, the linear solution procedure is not applicable to this problem. Same thing, if the sine t here is, for example, 4 delta t, then we cannot do the method of undetermined coefficient here. Okay, so most likely we will use the Laplace transform. Okay, so later, if you can look at the past year final exam papers, so normally you have something that involve the direct delta or Heaviside. Okay, because we want the student to apply the Laplace transform. Otherwise, you can use the methods that you have in chapter 1 and chapter 2. Okay, so that's basically the intention of this session. Okay, to solve the IVP and BVP using the Laplace transform. All right. So we are going to assume, okay, we are going to employ this formula here, what we call the transform of derivative here. So before this, okay, from section 3.1 up to 3.5, we use this notation. The Laplace of ft equals fs. Okay, and likewise, if we want to find the inverse to the fs, then the answer would be ft. Now, in the IVP and BVP, since we are dealing with the y in terms of t, okay, y in terms of t, so we need to use this new notation. So the Laplace of yt equals ys. All right. So in the syllabus, we only cover up to the second order ODE. Okay, which means that what you need to memorize is this one. Okay, this is the general one. The Laplace of yt equals the capital Ys. The Laplace of y prime. Okay, the first derivative, because we are going to replace, okay, we are going to use the transform here for the y dy dt here. So this dy dt will be replaced with this one. Okay, so you need to memorize, you need to remember the transforms s y s minus y naught. And for the second derivative, so the Laplace of y double prime equals s square ys minus sy naught minus y naught prime. Okay, so you need to remember three formula here. Okay, so but somehow in the table of Laplace, okay, if we can look here in the table of Laplace, it is given here actually, this one. Okay, so this one correspond to this one, the general one here. Okay, it's just that in the table of Laplace, the notation is slightly different. Okay, so you have the dnft. So when n equals 1, for example, then you have df dt. So df dt is the first derivative. Okay, what we normally have in the problem is in the form of y instead of f. Okay, so this one, the capital F here, okay, will be replaced with a capital Y. Okay, so on and so forth. So I would suggest you just remember, you just memorize these three formula. Okay, because I can see from my past experience, okay, students are confused with this one. Okay, tend to write capital F instead of capital Y. Okay, so you might want to memorize these three, okay, rather than memorize the general one here or refer to the table of Laplace. Okay, so to solve the IVP and BVP, so basically you will do this 4 steps. Okay, the first step, rewrite the equation in terms of Laplace transform. Second step, insert the given initial conditions. Third step, rearrange the equation to give the transform of the solution, and finally determine the inverse transform. Okay, so in section 3.6, you are going to do both. Find the Laplace transform, and at the end, find the inverse. Okay, because the intention of solving the IVP and BVP, okay, if we refer to these two problems, so our aim is actually to get what is y in terms of t. So we want to know what is yt at the end. Okay, so that's why at the end, okay, we need to find the inverse transform. Okay, because we know by taking the inverse, then we'll get the function in terms of t. Okay, so I'll explain more on these 4 steps using the given example that you have in your lecture notes. Okay. Example 23, solve the equation dy dt minus 2y equals 4 given that t equal to 0, y equals 1. Okay, and I put the transform of derivative at the right hand side here. Okay, so that we can refer easier to be referred. Okay, so first of all, look at the given condition. So you have t equal to 0, y equals 1. Okay, or can be written in this form, y0 equals 1. And in this section, this one is actually y naught. Okay, so in the formula, okay, we have the y naught here, and this is another one. Okay, so whenever we have the y naught in the solution, then we are going to replace with 1. Okay, so y naught equals 1, okay, your initial conditions. All right, so first step in solving the IVP by the Laplace transform is to rewrite the equation in terms of Laplace transform. Okay, so this is the equation. So dy dt minus 2y equals 4. So we are going to take the Laplace to every term in the equation. So it means we have the Laplace to the y prime. Okay, I just write dy dt to be y prime. Okay, minus 2y. So by the linearity, we can take out the 2, and then the Laplace of y equals, at the right hand side, we also need to take the Laplace transform. Okay, so the Laplace of 4. Okay, before we proceed, I would like to highlight here, because the common mistake, students tend to forget to take the Laplace on the right hand side. They just did on the left hand side. Okay, so you need to be very clear. In the first step, we need to take the Laplace to every term that we have in the equation. Okay, so both sides of the equation, left hand side and right hand side. Okay, so now the Laplace of y prime. Okay, look at the first term. The Laplace of y prime by the formula here. So you are going to replace the Laplace of y prime to be sys minus y naught. So we rewrite further. So this is s ys minus y naught. So that's Laplace of y prime minus 2 times Laplace of y. Okay, so by this formula, the Laplace of yt equals ys. So we have ys equals at the right hand side, so we need to think or refer to the table. What is the Laplace of 4? Okay, so 4 is a constant, so this is 4 over s. Okay, so that's what we have. And then second step. Step number 2, insert the given initial condition. So our initial condition, okay, in the problem is 1. So y naught equals 1. So this is our initial condition. Okay, so based on the previous step, okay, so we have sys minus y naught. So now we are going to replace that y naught to be 1. Okay, minus 1 minus 2ys equals 4 over s. Okay, so later in the final exam, you can automatically put the y naught straight away in the first step. Okay, so this is just a guide for you. Okay, step by step guidance. Okay, but in the exam, you can skip few steps, okay, to save your time. Okay, so that's the second step, to insert the given initial condition. Okay, third step is to rearrange the equation to get the ys. All right. So the intention of this step here, step 3, is to factor out the ys that we have. Okay, because we can see we have ys here and this is another ys. So we can group together the ys and try to put the ys to be the main subject. Okay, take the ys to be at the left hand side and the remaining terms to be on the right hand side. Okay, so by doing that, we have ys. So in the bracket, it should be s minus 2, right? So ys s minus 2 equals, so we have at the right hand side 4 over s. So take negative 1 to be at the right, so it is plus 1. Just a little bit of algebraic here. So ys then, okay, is 4 plus 4 over s. So this one is actually 4 plus s over s. All right. So ys is 4 plus s over s minus 2. So it is this times s minus 2. Okay, so that's our ys. And finally, okay, we need to take the inverse, okay, take the inverse transform to ys that we have here to get the yt. Okay, so yt is the inverse to the ys. Okay, which means we need to take the inverse to the 4 plus s over s minus 2. Okay, so normally student lose marks at this part here. Okay, because in this process you need to go back to the previous sections that we have so far and think what is, okay, the technique that is applicable to this one. So 4 plus s over s times s minus 2 actually can be mapped to the partial fraction that we have in previous subsection. Okay. So by the partial fraction, so we know that 4 plus s over s minus 2 can be written in the form of a over s plus b over s minus 2. Okay, so 4 plus s equals a s minus 2 plus bs. Okay, so cut the story short for this one. A is supposed to be negative 2, b equals 3. Okay, so it means that back to the inverse here. So this is equivalent to the inverse Laplace to the a over s. So a is negative 2, so negative 2 over s plus b. B is 3 over s minus 2. Now we can map to our table, okay, easily. So the negative 2 over s, okay, is negative 2. Okay, because we know the inverse to the k over s is k. Okay, so similarly here, the inverse to the negative 2 over s is negative 2, and the inverse of 1 over s minus 2 is exponent 2t. Okay, so we have 3 exponent 2t. So this is our yt. Okay, so for this particular example, okay, since we have just a very simple equation here that we know this is separable equation. At the same time, this is also linear equation. Okay, so if you have extra time in the exam, okay, then you can check with the method that you have in chapter 1. Okay, or basically you find the dy dt, okay, and try to put back here and minus with the 2y, see whether you get 4 at the right hand side. Okay, so that's how you check your solution here. Okay, so this is the 4 steps that you need to do, that you need to employ in solving the IVP. Okay, so we are going to take to see the second example that involve the y double prime. Okay, so this is now the BVP. All right. Example 24, we have the second order ODE. Solve the equation y double prime minus 3y prime plus 2y equals 2 exponent 3t, given that y0 equals 5 and y prime 0 equal to 7. So first of all, the condition here, y0 equals 5, simply means y not equals 5. And then y prime 0 equals 7 simply means y not prime equal to 7. Okay, so first step in solving the BVP, so first step is to rewrite. Okay, rewrite the equation in terms of Laplace transform. Okay, that is the first step. So it means we have the Laplace to the y double prime, okay, minus 3 Laplace of y prime plus 2 times the Laplace of y equals 2 Laplace of exponent 3t. Okay, that is your first step. Okay, and then replace the Laplace of y double prime to be this one, and Laplace of y prime to be this, and Laplace of y to be ys. Okay, so we have here s square ys minus s y naught minus y naught prime. So that is Laplace of y double prime minus 3. Okay, Laplace of y prime is s ys minus y naught. Okay, careful with your brackets and so on. Plus 2 Laplace of y is ys equals, at the right hand side, you have 2 Laplace of exponent 3t. Okay, so for this one, this is 1 over s minus 3. So we have 2 over s minus 3 at the right hand side. Okay, step number 2, insert or put the initial condition. Okay, we have 2 y naught and y naught prime. Okay, so we have here s squared ys minus s y naught. Okay, so y naught is 5. Okay, so we actually have the 5s here. Okay, minus y naught prime. Y naught prime is 7, so minus 7 minus 3sys. Okay, so be careful here. We have negative 3 times negative y naught, so it is actually positive. So plus, okay, 3 times the y naught. Okay, so y naught is 5. So 3 times 5 is 15. So I straight away put the plus 15 over there. Plus 2ys equals 2 over s minus 3 at the right hand side. Step number 3, get ys. Or in other words, make the ys as the main subject. Okay, so we factor out the ys. So ys, okay, you factor out. And then in the bracket, we have the coefficient of ys, which is s squared. Another term, we have negative 3s, so minus 3s, and lastly plus 2. Okay, so we factor out the ys over there, and the remaining terms to be on the right hand side. So we have 2 over s minus 3 plus 5s, and this negative 7 can be simplified with the positive 15. So we have minus 8 at the right hand side. Okay, which means that ys then, okay, so before that you can see these terms here can be written in the form of bracket times bracket. Okay, so try to simplify your quadratic expression, because previously in previous subsection we have seen that this one should be written in this form if possible. Okay, otherwise you do the completing the square. So at the right hand side, this is 2 over s minus 3 plus 5s minus 8. So ys at the left hand side should be, so everything that you have on the right hand side need to be divided with a s minus 1, s minus 2. So you can imagine the whole thing here is divided by s minus 2. So s minus 1 and s minus 2. So we can cancel out that one. So which means that ys equals to 2 over s minus 3, s minus 1, s minus 2 plus 5s, you can put together, minus 8 over s minus 1, s minus 2. Okay, lastly, step number 4, find the inverse to the ys to get your yt. Okay, so first of all, we try to simplify our ys, okay, because we know if we normalize the denominator, then we are going to have denominator here. So we are going to have s minus 1, s minus 2, s minus 3. So at the top we have 2 plus 5s minus 8 times s minus 3. Okay, which is, so at the top we have 2 plus 5s squared minus 15 and 40. So we have minus 23s plus 24. So at the bottom remains. Okay, so at the top, this 2 and 24 can be simplified further. So we have 26. And then at the top, this is actually 5s minus 13s minus 2. Okay, 5s squared minus 23s plus 26 can be written in the bracket times bracket like that. So we can see we can cancel out s minus 2 at the bottom. Okay, so you can see we can simplify s minus 2 at the top and also at the bottom. So it means that our yt, which is the inverse to the ys, is actually the inverse to the 5s minus 13 over s minus 1 s minus 3, which, one more time, can be referred as partial fraction. Okay, so by the partial fraction, you need to rewrite 5s minus 13 over s minus 1 s minus 3 to be in the form of a over s minus 1 plus b over s minus 3. Okay, so a little bit of competition here. So cut the story short, this is supposed to be a is 4 and b is 1. Okay, so make sure you get that. Okay, I'll just give you the answer for a and b. So finally, your yt is then equals to the inverse of a, which is 4. So 4 over s minus 1 plus b is 1 over s minus 3. So by the table, this is now straightforward. This is 4 exponent of t plus exponent of 3t. So that's your answer yt. Okay, so this is how do you solve the BVP, okay, the second order differential equation by using the Laplace transform. All right.